Yeah, so we continue with another one example, which is the application. Okay, application of PDE. This is about wave equation. Okay, wave equation. Gelombang ataupun gelombang lah, wave. So the question here is determine the solution of the vibrating string. Okay, string vibrate. When it vibrate mesti ada wave kan? So with vibrating string, problem governed by the given initial boundary problem. So this is the equation, and for this question you lucky because it already stated this is a boundary and this is initial. So you don't need to identify by yourself, okay? Like the previous one, you need to identify by yourself. You need to understand well the question is, and then classify which one is BC and which one is IC. But for this question, it's already given and it's already stated. But class, if you can see the difference here between the wave equation and the previous one heat equation is on the number of initial condition. So initial condition here, they have two. Okay, this is the first one, and then this is the second one. So they have two initial condition. For the heat equation just now, in the previous video, it given to you only one IC. So can you predict what we will can you expect what you will face it? What I mean here actually, wave equation is more complicated a bit compared to heat. Every time for wave dia macam panjang sikit lah dia punya step because they have two equation of IC. So means that you have another one or another extra things that you need to calculate. Okay, so without further ado, we will start. So as I said, the first step will be the same, which is you need to make it or you need to show it separable or not. That's all for the first step. So we do it now. So you just substitute with this equation and then you divide by T double prime over T, X double prime over X. Okay, so then you can see obviously it's a separable. So it's separable. Okay, it's a separable. Okay, then we will proceed with step number 2. Okay, to proceed step number 2, we start with case 1 lah, of course. We will start with case 1, where is K is equal to lambda square. So the equation, continue here first. So what's the equation here? The equation here is X double prime over X equal to K, and T double prime over T equal to K. Oh my god. Okay. Right. So case number 1, X double prime over X equal to lambda square, X double prime minus lambda X equal to 0, M square minus lambda square equal to 0, M square equal to lambda square, M equal to plus minus lambda. Okay, so yeah, like what I was said before, you will face or you will see this again. Dia benda yang sama je, equation yang sama je yang you akan buat. Okay, so this will be X. Equation is C1E lambda X plus C2E negative lambda X. Okay, then your BC, what is your BC? U0T equal to 0. Okay, so you just substitute lah. Okay, C1 plus C2 equal to 0. Okay, this is the first equation. And then the second BC is U1T equal to 0. Therefore, you will get C1E lambda plus C2E negative lambda equal to 0. This is the second equation. Okay, so you do it the substitution. Okay, I don't want to show it here. I just want to proceed. Okay, therefore your C2 will be 0, C2 and C1 is 0. So then you need to omit the case. Okay, alright. So now we go to case number 2. K0. So X double prime over X equal to 0. So X double prime 0, M square 0, M equal to plus minus 0. And then X equation here, C3E 0x plus C4x E0x. Therefore you have C3 plus C4x. Okay, then your BC U0T equal to 0. So means that you have C3 equal to 0. And the second BC is U1T equal to 0. So therefore U1T will be C4 equal to 0. Okay, kan benda sama kan? So then what else? So we omit the case. Okay, alright. Then we go to case number 3. And definitely, as I mentioned, case number 3 cannot be equal to 0. Okay, wait. Is it okay? Oh tak. Okay, case number 3. Definitely, yes, they have is. You need to careful, like it cannot be equal to 0. It means that you need to make it some adjustment, like you need to find what's the value of lambda. Okay, so x double prime over x equal to negative lambda square. So x double prime plus lambda square x equal to 0, m square plus lambda square equal to 0, m square equal to negative lambda square, m equal to plus minus lambda I. Okay, so I really hope that you score for, maybe lah for the next one will be difficult for you, but I hope that case 1, case 2 and case 3 until here you get the marks, because it just repeated thing. If you do it the exercise, even though you repeat the same question also, you will when you are answering the different question, I believe that you can buat laju je untuk case 1, case 2 tadi, confirm. So, but dengan syarat you buat lah. Janganlah you tengok je, you kena buat. Alright. Okay, so this is equation of case 3. So which is C tadi, C5 cos lambda x plus C6 sin lambda x. Okay, mesti sama. Dia akan dapat sama je. Okay, then your BC just now U0 what tadi? Saya lupa dah. U0T. Okay. So just substitute lah kat situ your value, which is at 0 here. So you have C5 and this is equal to 0. Okay, just write down the final answer je. Okay, so then the second BC, U1T equal to 0, and then therefore your x1 is equal to C5 is already 0, so C6 sin lambda. Okay, because your x is equal to 1, right? So equal to 0. C6 cannot be equal to 0, therefore sin lambda equal to 0. So what is your lambda here? So you need to try and error. Sin 0, what we have? 0. So therefore the first number is 0. Sin 180, sin ni tak boleh. Sin 90 tak boleh. Then sin 180, 0. So then sin, because we already do it just now, right? So means that sin next is sin 360 lah. And then 3 pi and dot dot dot. Okay, because we already do it just now in the exercise or in the example heat equation. Even though it's a 4 lambda. Okay, 4 lambda dengan lambda tak ada beza. Cuma 4 lambda tadi kalau if you refer, because okay, maybe nanti saya takut nanti ada orang tengok video ni sebelum tengok video tadi. So I just explain here. So just now we calculate 4 lambda is the same thing that we have this pattern, right? So now we are doing 4 lambda. Actually it's the same thing lah. Okay, beza dia cuma nanti dekat sini lambda u akan divide by 4. Each of it akan divide by 4 lah. Okay, right. So this one is just lambda. So yeah, imagine lah you bahagi dengan setiap ni 1. Okay, alright, tak apa, tak ada. Rasa tak penting kot yang tu. Okay, so this is how we find the lambda. So you can see the pattern here. So means that it will be from n pi. Okay, it will be n pi because as I mentioned before this, the pattern here is increasing order, which is start from 0, but we can ignore the 0, so we start with n1, 1 here, 2, 3, and so on. So it will be until infinity. So therefore, it's from, you can write 0 actually, but yeah, 1, 2, 3 lah. Okay, 1, 2, 3, and so on. Okay. So therefore, what is the equation for x? The equation for x is given by this just now. So C5 is already 0. So you left with C6. So we still have C6. And then sin, okay, lambda now you replace with n pi x. So you need to write this way. Okay, you need to write xn. So therefore this is cn, this is n pi x. Okay, so this is your x equation class. So now we will do it for t double prime. Okay, we will do it for t equation. Okay, t double prime equal to negative lambda square. So t double prime plus lambda square t equal to 0. M square plus lambda square equal to 0. So m equal to plus minus negative lambda square. It become plus minus lambda I lah. Okay, then your t equation is equal to tadi c. So now c7 cos lambda x, sorry, lambda t plus lambda t, because we are doing for t equation now, plus c8 sin lambda t. Okay, alright. Okay, then you need to substitute. Okay, this is also become tn, so this one is c7, this one is cos n pi t. Okay, you replace every time you have a lambda here, you replace with n pi plus c8 sin, oh sorry, this is the t equation. Okay, suppose you use a different alphabet, tapi tak apa. Okay, tak apa, kita proceed je dulu. Okay, because as I mentioned, alphabet tu tak penting pun apa-apa, cuma nak make it standardized. Okay, supaya bila saya marking tak adalah saya keliru banyak sangat, nanti orang ni guna huruf ni, orang guna huruf ni kan. But it's okay actually. Okay, so this is your t equation. So you have t equation and then you have your x just now. So you just substitute here back. So what is your x just now? Cn sin n pi. Okay, and then your t equation, this one, that's why because of c7 and c8 is fixed, right? So kita tak nak guna, so kita akan ganti dengan n. So that's why kita tak boleh guna c, sebab kalau kita tulis cn, so it become same like this. Actually it's different, dia punya tu different. So maybe I can use, kalau if I refer to textbook here, is use a. Okay, use a. So maybe you can use a lah juga. Okay, alright, an, bn. Okay, so an here cos n pi t plus bn sin n pi t. So you will multiply this. Okay, so careful kat sini dia ada dua term. They have two term which is plus here. So and then this, so it will be cn with this term will multiply with this term and then plus. Okay, so where cn times an is equal to, let's say I let as an, and when cn times bn, I will let as bn. Okay, so it become an sin here, dia akan dapat 2 so careful kat sini. So dia akan dapat sin n pi x and then cos n pi t, and then plus cn times bn, we let as bn je tadi. So bn sin n pi x dengan sin n pi t. Class careful, these two is not equal. This is sin n pi x and this is sin n pi t. So it's different thing, different term. So you cannot multiply, or maybe some of you will power 2. It's wrong. Okay, careful class, it's wrong. Okay, so this is the answer, or this is the ni. So now we want to make it in term of summation. Okay, so just combine this all. Okay, so kalau you tengok kat sini ada sin n pi x, kat sini pun ada sin n pi x. So why not we factorize it? Okay, I factorize. Okay, I factorize because both have sin n pi x. So I factorize sin n pi x. So I just leave it this inside here. Okay. Alright, so you will get this term. Okay. Alright. So next, what we do next? So kat sini, if you can compare with the previous example, we just have bn. We just have bn to find out the answer for bn, then we substitute the answer inside the equation here. But now you have an and also bn. So but before that, okay, you need to apply the first IC. What's the first IC just now? The first IC is u at 0 equal to x minus x square. X minus x square. So you will substitute t0 inside here, okay, inside this equation. So you will get what? Summation n1 infinity an cos n pi 0 plus bn sin n pi 0 and then sin n pi x. Okay, so simplify. So you left with an 1 kan, cos, so habis lah. I mean they have 1 x 1 lah, equal to 1. bn sin ni habis. So you just left with an sine n pi x. Okay, so this is the first IC. Okay, you ada dua IC kelas, you ada dua initial condition. So this is the first one. So we want to solve this one first. Okay, you need to find your an first. So find out your an. So what is your an punya equation? Okay, it's basically the same, 2 over L, 0L, fx, and then still sine n pi x. Okay, jangan confuse. An ni bukan refer to the previous chapter Fourier series. No, this is just the equation is already fixed. Okay, and sine n pi x ni we take it from this equation. Okay, and then your fx is from the IC. So what is your L here, class? What is your L? The question here is, okay, you can refer back to the interval given here. It's from 0 until 1, is it? 0 until 1. So means that the L here is 1 lah. So 2 over L is 2 over 1, 0, 1. So fx here is just now is x minus x squared. And then you have sine n pi x. So you do it the tabular method again here. So so they have x minus x squared, 1 minus 2x, negative 2, 0. Okay. Alright. So you complete lah this one, okay? You fill up this one. Then you solve it. So supposedly your an here is 4. Okay, I just write the final answer, class. Okay, power 3. Okay, this is your n. But if you refer to the slide ataupun the slide lah that I upload in Ulearn, they have another two, which is kalau you tengok kat sini saya tunjukkan. You have 0 and 8 over n pi power 3, and this 0 if your n even, and for this term if your n is odd. So I think tak perlu kot, I think you just ignore this part. Okay, so just stop until here, which is the final answer that you get for an is for this one. Okay, for n negative 1 power of n plus 1 ni, dan ni je. So tak perlu nak, tak perlu nak split which one is odd, which one is even. Okay, you just leave it like this. So now we proceed, or we continue with the IC number 2, class. Okay, the second IC given here is du dt, right? And then du dt is equal to when t0, this one equal to 2. So what does it mean? Okay, you need to differentiate. You need to differentiate your equation ux just now. This is your equation ux. This one. Okay, this one. So now you will differentiate this one. Okay, you need to differentiate, class. You need to differentiate. Okay, saya tulis balik lah equation dia. U x t equal to summation n, and then you have a n cos n pi t plus b n sin n pi t sin n pi x. Okay, so this is the equation, and then you need to differentiate. Okay, differentiate first baru you boleh masukkan nilai. Okay, differentiate first, then you can baru it just can substitute this value of t. Okay, you need to differentiate first. So how to differentiate, class? So just differentiate lah u prime xt. Summation is remain. Okay, tak ada beza pun, summation tu kan ada. So you have two term here, this term and this term. So means that they have two term. So you need to one thing. Yes, betul lah, two term. So means that you need to differentiate by using the product rule. Okay, product rule. Okay, class. So uv prime plus vu prime. Okay, using a product rule. So therefore you should get, okay, kita buat satu-satu lah. So u. So let's say this is u. So a n cos n pi t plus b n sin n pi t. Okay, this is u. And then v prime. So this is v prime. This is v. So you need to differentiate. So you have differentiate sign, you akan dapat cos n pi x. Sin n pi x, class. So this is sin n pi x. So means that you need to differentiate this with respect to what? You tengok balik. You differentiate with respect to t, class. T. This is x sin n pi x. They have no t. So that means is equal to 0. Saya pun dah almost nak buat silap tadi. So careful because of we are differentiating with respect to t. But here our sign here is sin n pi x. Okay, so means that it's not related with t. So it's just a coefficient. So when you differentiate it, you will we will get 0 lah. Okay, so we settle for this part and then plus v u prime. So what is your v? Your v is sin n pi x. Okay, times with u prime. So u prime here is this one lah. You need to differentiate. So a n cos. So differentiate cos akan dapat negative sin. Sin cos. Negative a n n pi sin n pi t. Then plus b n n pi cos n pi t. Okay, right. So I'm really sorry because it's messy kat sini. Tapi I hope that you can slowly watch it and figure out what I say here. Okay, so you copy it back. So this one definitely nothing because 0 times this will be 0. So you just left with negative. Okay, I just write it back. Negative a n sin n pi t plus n pi b n cos n pi t. And then you have sin n pi x. So now this is the equation for u prime x t. Then baru you boleh masukkan value of 0 in your t. So you will substitute 0 in your t now. So this one sin n, so definitely 0. So this one is n pi b n. Cos 0 you have 1, so which is n pi b n. And then you have sin n pi x. Okay, and this equation you will equate to 2, right? Tapi tak apa, kita biar dulu. Alright, so now you have this term. You have bn here. You have bn. And together with n pi lah. Okay, so what we do next is, okay, we want to find the bn. Okay, we want to find the bn class. But you need to bring together lah n pi bn. Okay, it's all this, you need to bring it. Even though we want to find bn only, but you need to take it all of this. So the formula will be same, 2 over L, 0L, fx sin n pi x. So 2 over L is 2 over 1, so 0, 1. Okay, fx now is 2. Okay, from where you get 2? From the initial condition, from here is equal to 2. Okay, and then sin n pi x. Okay, so this one simple lah, simple. Sebab dia tak ada, so means that you don't need to use what we call, to use the tabula because this is only constant 2. So just bring out lah, just to bring out the 2. So you have this. Okay, so you solve it, sin n pi x. Okay, solve it. So the final answer that you should get here is 4 negative 1 power n plus 1 plus 1 over n pi. Okay, alright. So then class, you see, this is n pi bn. N pi bn is equal. So what? But we just want bn. Ataupun tak perlulah, serius tak perlu, tak apa. So n pi bn lah. Okay, n pi bn to equal to this. So the final answer, not final answer yet. Yeah, final answer lah. The final answer ux. What is your ux tadi? Uxt equal to summation of n1 infinity an cos n pi t plus bn sin n pi t and then sin n pi x. So you just substitute that what we have just now. An, what is your an tadi? Saya dah banyak sangat dah kertas kat sini. What is your an tadi? Let me see out. Your an is 4 negative 1 power of n plus 1 over n pi cube cos n pi t, okay, plus bn. What is your bn? Okay, class, this is not your bn, this is, as I mentioned just now, this is n pi bn. So to get bn, so you just okay, saya tulis balik lah kat sini. Okay, we want bn only, so you need to bring your n pi, is it, to this side. So dia akan jadi bahagi, betul? So means that you will get negative 1 power of n plus 1 plus 1 n pi square. Okay, you will get n pi square lah. Okay, alright, so 4 negative n plus 1 over n pi square. Okay, bahagi bila bahagi kat bawah, so dia akan jadi kuasa 2 lah sebab dia repeated to n pi here. Oh, sorry, sin n pi t, sorry class, I'm missing out this one, sin n pi t and then sin n pi x. So this is the final answer, class. Okay, just substitute lah what is your a and your bn just now. So for wave equation is a bit lengthy. Okay, dia panjang sikit lah because they have two IC, dua initial condition that you need to find out two value an and bn. Alright class, so I think that's all for this week. So this week is just I explain to you the example of the application that we will be asked lah, a type of equation or a type of application that implement the partial differential equation. Okay, so yeah, that's all. So for the another more topic is still PDE, but there is what we call the different approach, which is a numerical approach. What we have done just now and the previous week is a analytical. Okay, so bear in mind, so they have two different way, analytical and numerical. Alright class, so thank you.